Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. Though my videos are uh, too many, complete, and it discusses almost everything, I hope that my lecture videos and sample problem videos are important to your studies. So please don't forget to subscribe. By the method of least work, find the horizontal component of the right reaction of the arc thrust shown below due to increase of temperature of 28 degrees Celsius in bars A, B, B, C, C, D, and DE. No change in remaining bars. Cross-sectional areas in square millimeters are shown in parentheses. Modulus of elasticity 207 gigapascals and the coefficient of thermal expansion beta 12 times 10 to the negative 6 per degree Celsius. So here is the figure. This thrust is taken from example 158G and the load is removed. So we have 1 degree of indeterminacy and we choose EX, the horizontal component of reaction at E as our redundant force. So this is also EX to the left, then the slope of the inclined members. For members with the same cross-sectional area, let's have color coding here and denote the following forces. So as mentioned in the preceding slides, the statics will be left to you to verify. So I'll just put the values here. We analyze only the left half because the truss is geometrically symmetrical and we need only to analyze the left half or the right half. So here the left half. So show by statics that the force in AF in terms of this horizontal component reaction is 1.118 EX, then AB negative 0.5 EX. You proceed to B, show that this is negative 0.559 EX, and BF would be positive 0.559 EX, and CD is since equal to BC, therefore you can analyze this CF equal to 0.5 of EX. Then let's tabulate. So for member AB, we have negative 0.5 EX, partial derivative negative 0.5. The length is 3 meters and the product is 0.75 EX. And we also need the product of the force or partial of S with respect to EX, then the thermal expansion beta L delta T to accumulate the total displacement caused by this temperature change. So negative 5.04 times 10 to the negative 4, that is negative 0.5 times beta, which is 12 times 10 to the negative 6, length of member AB, because this is affected by temperature 3, then delta T is positive 28, and that's the result. For member EF 1.118 EX, partial derivative 1.118, the length is 3.354, then the product here, then AF has no contribution to temperature change, so that's 0. BC, it's negative 0.559 EX, partial derivative negative 0.559, the length is 3.354, and the product here is partial of S with respect to EX times length 1.048 EX, then EC is involved, so negative 0.559 times beta times length, its length times delta T, it will give us negative 6.3 times 10 to the negative 4. For BF, 0.559 EX, partial derivative 0.559, length 3.354, product 1.048 EX. BF has no contribution to temperature change, so it's 0. And finally for CF, 0.5 EX, partial derivative 0.5, length 3 point, length is 3, then product, then 0 because it has no contribution to temperature change. Therefore, the sum of this last column is equal to negative 1.134 times 10 to the negative 3. So that is equated to the sum of this divided by AE, area times E. Then only for CF where we have to multiply one product by particularly this CF here by 0.5 because though symmetrical, it is the only one member. All other members have identical members that we just copy whatever values they have in this column here, except for CF where we have to multiply one product here by 0.5. So negative 1.134 times 10 to the negative 3 is summation of S, partial of S with respect to EX times L over AE, and that is equal to, for this member here, so 0.75 EX plus the other one should be multiplied by 0.5 or half of this, then divided by times 1000 to convert it to, the numerator is in kilonewton meter, so to make it meter, to make it Newton meter rather, the numerator. So we multiply 1000 so that kilonewtons will be in newtons. The denominator is area in mm squared, then this is in Newton per mm squared, so the denominator is in newtons. The numerator is in Newton meter, so that is consistent meter. Then for the pink, 4.192 EX times 1000 over area, which is 7000, then E 207,000 megapascals. Then for the orange, we combine this, that's 2.096 times EX times 1000 over area 10,500, then E 207,000. So simplifying, so we have 9.1848 times 10 to the negative 4 EX times 1000 over 207,000 equals negative 1.134 times 10 to the negative 3. So solving for EX, it is negative 255.572, so opposite to this direction, therefore EX is to the right, 255.572 kilonewtons to the right. So that's the value of EX.